quickly the alternator because the people make a lot of mistakes in the selection of the alternator, in the replacing of the alternator, in the installation of the alternator, in the troubleshooting of the alternator. The alternator is a vital component in a boat. Every day is more sophisticated. Today, because the majority of the boats are in the process to be converted in a hybrid or fully electrics, especially in sailboats, some people want to install bigger alternator with the huge capacities to keep the battery bank of the house fully charged, the battery bank of the inverter fully charged with that alternator. Yes, it's possible, but you need strong engines. And you need to run the engine continuously. I don't recommend. Okay? But there are a lot of alternators with huge capacities today. A lot of capacity. And now I am going to explain how the alternator works and what is our recommendation, the recommendation of Danny and me. Okay, suppose that I have the piece of iron, guys, the piece of iron, and I am going to insulate one piece of one segment of the piece of iron with a plastic, with a heat string, and I am going to wrap it, a coil over there, no? A coil, and I am going to bring the beginning and the end of those wires here outside. And I am going to prepare a couple of washers, metallic washers. Metallic washers. I have one metallic washer here, and I have another metallic washer here, equal diameter, and the same diameter in the center equal to the diameter of the shaft. Look at this. Suppose that I cutted some sections in both washers. I cut it, yeah? I cutted those sections in both sides. And I am going to weld those washers here. Those washers pre-cutted. And after that, I am going to bend it, those parts. And finally, I have that situation. You see? This one is bended, the other one is bended, and the coil inside. Anybody follow me? Yeah. Now what happened? Now I have this situation. This one is bended here, this one is bended here, and I have pieces of metal like this, and this one enter here, and this one enter here. Yeah? One is positive, negative, positive, negative, positive, negative. No? Both of them bended like this. Yeah? These ones are positives because this side is positive, and this side is negative because this one is connected to the battery, to the positive and the negative, and this piece of metal becomes magnet. Okay. This washer will be negative washer, and this washer will be the positive washer. The positive washer. And you have positives and negatives, magnets. And after that, I am going to create a coil. How you create the coil? You create the coil in this way. You see? You start with one wire, continue, 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 and finally you have both wires, positive and negative, the beginning and the end of the coil. This is a coil. And I am going to rotate in the center the magnets. I have the coils here, I have the coil here, and the coil here. And what happened with the magnets when the magnets are rotating in front of the coil? The coil produces, this is hot, this is neutral, and this is the ground. The coil produces AC current. And now I enter that AC current in a group of diodes, organized and capacitors, and rectify the AC current into DC. And at the end of the day, after the current passed through the rectifier and 1 voltage regulator, you have here positive and negative, positive and negative. If this alternator is for 12 volts, the output will be 14.2, 14.3, 14.6 maximum. That's okay? Yes, internally the alternator produces AC current. At the end, in between this and this, is DC current. For that reason, the alternator is considered a source of DC. Can I put here one handle like this and I move it with my hand? Yes? But what happened in 5 minutes? Or can I connect this one to my bicycle and in the bicycle? Yes. Or can I connect here a turbine and I put a jet of water and with the water? Yes. Or can I put here a fan and I use that one for a windmill? Yes. You can spin the shaft. Can I connect a small gasoline engine? Yes, my friend. And you produce AC current. And after that, DC. You understand? This is a generator. Can I connect here a turbine and here a boiler? The water boil, produce vapor, and with the vapor, spin the turbine? Yes. There are millions of possibilities. But this is a small generator. How you bring the current here in the middle? Follow me. You have a plastic washer. It's plastic. And you have another plastic washer here. And those washers in plastic are covered with a copper rings, similar to the ring that you have in your finger. It's copper ring, and the copper ring will be covering the plastic washers. What is the meaning of that? The copper ring is touching the shaft? No, because it's isolated for the plastic. Everybody follow me? Okay. In each copper ring, I connect one end of the coil. And now the copper rings, they are connected with pieces of carbon. Pieces of carbon. And those carbon have a spring here, and one of these is negative, one of these is positive, and this one is connected. You remember the switch? This is ignition, this is a start, and this is battery. The ignition switch receives the power from the positive battery bus bar. And this cable will be purple color, connected to the ignition. And this one is the ground, connected to the ground of the battery. Okay, when you activate the ignition switch in the position ignition, you bring current to the coil in the middle. And what happens with the metal? Become magnets. Pay attention. I bring the current here into the carbon, the graphite touch the metal, the rings, and when the metal is powered, the metal powered the coil. When the coil is powered, those metals are positive and negative. That's clear? Okay. Depending on how strong are the magnets, when the magnets are spinning, produce the AC current. What is the name of this current coming here through these brushes? Those are the brushes. This is the excitation. Enter here, activate the coil, and the coil produce the magnets. And this area is the exciter. All the motors, all the alternators, they have the slip rings, and the brushes enter here. What happened, guys? When I have oil or contamination in between the carbon, the graphite of the brushes, and the slip rings? The excitation is low. Low excitation, poor excitation. And what about the output voltage? It's not good. For example, look at this. Thank you, Dan. This is the slip rings, you see? And the brushes enter over there. I have a question. My alternator, I put my car in a shopping center in front of a glass, a window, and I see the lights of my car. When I accelerate the motor, I see the intensity of the lights good. When I decrease the RPMs in the motor, the intensity of the lights decrease. What is the meaning of that? Excitation is not good. The brushes are contaminated with oil. If you accelerate a lot, the contact is good. If the acceleration is low, the contact in between the brushes and the slip rings is not good. It's poor excitation. You need remove the alternator, send to the machine shop, they remove the brushes. Oh, the brushes are wear. They replace the brushes for new ones, and they, with sandpaper, clean the slip rings. New brushes, clean slip rings, start again. Oh, wow, good intensity. You understand? It's bad excitation, poor excitation. What is the symptom? Normally, the alternator, ABYC question, the output of the alternator is in between 12.6 and 14.1. This is the output of the alternator. It is an alternator for a 12 volts battery bank. What happens if my alternator is producing 12 volts? Is good output?
No.
It's a little low. Probably the exciter is contaminated. No? Excuse me. My alternator is producing 16 volts, 17 volts. Is good?
No.
Why is not good?
Pulley is too small, it's spinning too fast.
You can overcharge the battery bank if you don't have a.c.r. You can damage the battery. What is damaged internally in the alternator? The voltage regulator. It's an element at the end of the alternator that regulates the output in between 12.6 and 14.2. If that regulator is not good, the output is higher. The alternators, they have in the label here, the capacity in amps. Exactly the same than the battery chargers. If the alternator in the label says 60 amps, what is the meaning of that? Correct. In 1 hour, produce 60 amps. The recommendation is this. If my battery bank, this battery plus this plus this plus this in series parallel or series parallel combined, the capacity of this battery bank is 400 amps in total. The recommendation is a battery charger or alternator of 40 amps.
10%.
10%. Yeah? If the group of batteries is completely discharged, this is not good. What is the recommendation with the batteries?
50%.
No discharge more than 50%. Okay, suppose that is completely discharged. Not recommended. This battery charger or alternator need 10 hours to recover completely. The recommendation is 11 hours, 10% more. But my battery bank never goes down more than 50%. Okay, in that case, in 5 hours, that charger recover my battery bank completely. That's clear, my friends? This is, of course, if you install a battery charger or alternator a little bigger, you recover in less time. Good? Clear the explanation? What is the recommendation when you select the battery charger or alternator?
10%.
10% of the capacity of the battery bank. Finito. Finito. Okay.